Hi everyone. In the previous video we learned how to use our trig ratios to solve for missing sides of right triangles. We're going to expand upon that today and use our trig ratios this time to find missing angle measures in a right triangle. So I'm going to start with an example and then we'll backtrack through some notes from there. Now what we want to do is we want to find the angle measure, but it's going to stem from the same ideas as finding a side. So we're going to take a look at our triangle, see what information we have, what information we want to use, what information we want to find, and set up a trig ratio that works. So what I have in this particular problem is I have the short leg here 6, I have the hypotenuse is 15, and I want to find measure of angle Q and R. Now these are both unknown, so if there's two different unknowns, we're going to have two different equations. And let's just start with one of them. So starting with measure of angle Q, that's right here. I want to figure out what trig ratio represents the information I have, which is this angle, this side, and this side. So if I'm looking at angle Q and I'm standing up here, well, this 6 is going to be the adjacent side to Q because it's right next to Q. Now I know this is next to it as well, but this is called the hypotenuse. So I have the adjacent side, I have the hypotenuse, and I want to set up a trig function that kind of models adjacent and hypotenuse. So if I think of my SOHCAHTOA, which one is going to use adjacent and hypotenuse? And in this case, it would be the CA, which is the cosine. So for measure of angle Q, I'm going to use cosine, COS, and I'm standing at angle Q, because I have to take the cosine of something. I'm at angle Q. And that's equal to the ratio of the adjacent over the hypotenuse, which we don't need to write adjacent hypotenuse. We can substitute in the actual numbers there now that we know the relationship. So the adjacent is 6, the hypotenuse is 15, and there's my equation that's going to help me solve for the angle measure. So what I've just done here is nothing new. You know how to set these up already. What is new is how I'm going to get this Q alone, because I want to find the measure of angle Q, and maybe I should have even written here that it's angle Q, but I don't know how to undo this cosine that's bothering the Q, right? So like if I had 2Q equals 6, I could divide by 2 because division undoes multiplication, and 2Q is 2 times Q. But division undoes multiplication, it does not undo cosine, sine, or tangent. So I need to figure out, and maybe this is my essential question for today, what operation or operations undo my trig ratios? That's my essential question. That's what we have to learn today. Okay, so there are 3 trig ratios. Sine is one ratio, cosine is another ratio, and tangent is our last ratio, or the ones that we've learned about at least. So I want to know what undoes sine, cosine, tangent. And this is another new operation you need to learn. And luckily, they have a pretty easy way of remembering what undoes each one. Now, when I gave you that example, that 2Q equals 6, the reason we divide is because multiplication and division are inverse operations. Inverse meaning they undo each other. So someone was really creative and decided the inverse of sine should be called inverse of sine, or inverse sine. So inverse sine will undo sine, inverse cosine will undo cosine, and inverse tangent will undo tangent. Now, this is the name of the function. The notation that you'll see in the calculator or that I'll be using in my operation, you know, like technically addition is the name and plus sign is the operation. So this is the name, addition, but it's inverse sign. Now, the notation that you'll see in your calculator looks like this. Sine and a little -1. It's like sine raised to the negative first. That -1 is the universal mathematical symbol, meaning inverse. So inverse cosine is cosine of the -1. Inverse tangent is tan -1. Okay, and I'm going to write that down here as well. You don't have to write the addition thing. I was just giving an example. So that little -1 symbol is the universal math symbol, meaning inverse. You'll see this a lot in Algebra 2. Okay. So if you saw like this button on your calculator, that means x inverse, not x -1. So this is inverse sine, inverse cosine, inverse tangent. So inverse cosine will undo cosine. So if I want to get rid of that, I have to take the inverse cosine of both sides. So if I take inverse cosine of cosine, they're inverse operations, so they cancel. But whatever you do to one side, you also have to do the other one. Okay, so while these cancel on this side, then you're left with angle Q. On the other side, you have cosine of 6 divided by 15. And this is something you'll have to plug in your calculator to solve. I don't necessarily know off the top of my head. Okay, so your calculator makes a lot of sense. You see sine, cosine buttons here. The inverse functions are above them. So in order to access that yellow stuff, you have to hit the second button. So if I hit second, and then I hit cosine, I'll get inverse cosine. And you want to take inverse cosine of 6/15, or 6 divided by 15. So if you do that, and you hit enter, which I got to scroll this to hit enter, you should get the angle of Q. So that means the angle of Q is 66.42 degrees. So, and maybe I should say the measure of angle Q, M means measure, is 66.42 degrees. Okay, so that's what inverse trig ratios do. All three of these inverse trig ratios are functions that solve for angles, right? So the trig, sine, cosine, tangent ratios themselves are functions that solve for a ratio. Inverse solve for angles. Angles. Okay, ratio, angles. Ratio, angles, ratio, angles. Okay, I'm going to leave measure of angle R for you to try on your own. So, kind of got to erase the picture I've set up here. Now for angle R, you're using a different reference angle, which means you're referring to a different place that you're quote-unquote standing. So if I'm using R, here I am. And then you're still going to use these two sides because that's the information you have. But now you got to decide which of the three trig ratios is going to relate that information. You're going to set up an equation and you're going to solve it. Okay, or I don't have to give you a picture. I can just give you an equation and you should understand that trig ratios kind of will solve that equation. So for example, if I give you this, a little bit different, but same idea. So you have tangent of A is 3.29. First you need to understand what this says. Tangent is my trig ratio. A is my angle, because you always take sine, cosine, or tangent of an angle. 3.29 is the ratio, right? So often, I don't know what I'm writing there. Oftentimes you would see this instead of that, you would see as like 5/12, right? You would see ratio. Basically what the 3.29 is those numbers have been divided and you got a decimal instead. Okay, so if I want to solve for A, that's what it's asking you to do here, I know that inverse trig ratios solve for angles. Okay, or the other way you can think about it is I got to undo this tangent. And how do I undo tangent? Well, the inverse of tangent is called inverse tangent. So if I want to undo tangent, I'm going to apply inverse tangent to both sides. Because tangent and inverse tangent undo each other. Whatever you do to one side, you have to do to the other. So you'll get A equals the inverse tangent of 3.29. Which again, then now this is done in your calculator. So to find inverse tangent, it's above tangent. So here's inverse tangent. I got to take inverse tangent of 3.29 and hit enter. It'll tell you that A would have to be 73.09 degrees. 73.09. Okay, so measure of angle A, just to kind of repeat myself here, is 73.09. I'm leaving a couple for you to try on your own here. So that's basically how you'd solve for angles using the trig ratios. Now you've learned what inverse sine, inverse cosine, inverse tangent are, and you can use them to solve for missing angles. Okay, there are a couple more problems for you to try on your own on the back. Lots of different situations. So one is like a modeling problem. One is, set up the triangle, which you've seen before. They're all different ways you can apply the same idea. If you have any questions, please raise your hand.